So in chapter 6, we are learning all about exponents and radicals. So just to remind you, an exponent will have two things. It will have a base, and that's going to be the number at the bottom, usually bigger. It'll be in a larger font, and then we'll have an exponent at the top, and that is the number that takes the base number and multiplies it that many times. For example, like 3 to the second power. That's the same thing as 3 times 3, which equals 9. Now in this unit, we're not really going to be evaluating lots of exponents. We're mostly going to be learning about exponent rules. What happens when we have something like, I don't know, x to the second power times x to the third power. We're going to be learning all sorts of different rules pertaining to exponential expressions when they have bases that are variables rather than numbers. So the first part of this lesson introduces a monomial, which sounds like it's crazy, but a monomial is a number, a variable, or a product of a number and variable. And basically what it means, mono means one. It's going to be like a one-termed math expression. So an example of this could be like 3x. That's a monomial because it's one single term. Or maybe it's just a number, like 8. Or maybe it's just a variable, like y. Or maybe it's a number, like 5, x, and y. Even though we have three separate things, a number, a variable, and another variable, because it's a product, it makes it one number. Now, monomials with the same variables and exponents are considered like terms. And what we do is we can add or subtract the monomials if they are like terms by either adding or subtracting the number in the front but not changing the variables or exponents. So what we do is we add or subtract the coefficients. Let me remind you that a coefficient is the number in front of the variable. And then we do not change the variable's exponents. For example, 19x minus 24x. If we have 19 of them minus 24, 19 minus 24 is negative 5, so this would be negative 5x. Number 2, negative 19k squared plus 2k squared. Negative 19 plus 2 is negative 17, and then we keep the k squared the way that it is. So what we're doing here is we're just taking the numbers on the outside, adding those to get that number, and then keeping the variables exactly the same. It quickly gets crazy looking at the next one. Negative 12 r squared s to the third power t plus 4 r squared s to the third power t, but we still do the same thing. Negative 12 plus 4 of them is negative 8. And what is it? It's an r squared s to the third t. Number 4, 27ab squared minus 1ab squared would be 26ab squared. 7ab plus 4ac is a trick question. This cannot be simplified. This would end up just being the original answer because they're not exact like terms. One has the AB, the other one has A, but it has C instead, so not like terms. Negative 7CD plus 6CD can be either written as negative 1CD like that, or just negative CD. We can have some fractions added into the mix. That's totally fine. 2/3 x squared y minus 1/4 x squared y. You could use your calculator and just do 2/3 minus 1/4. We also could quickly find a common denominator and do this by hand. 8/12 minus 3/12. That would be 5/12. So this would end up being 5/12 x squared y. And I'm sure at this point you're kind of getting the hang of it. Now, things do start to switch up with number 9. We have multivariables. We have y's and we have z's. We can only combine things that are like terms. So this is going to be an answer that doesn't have one single monomial answer, but two. 2y minus 11y is negative 9y. 14z minus 10z is positive 4z. So my answer in any order, negative 9y plus 4z, or 4z minus 9y. Number 10, we've got two terms that are s's. 16s minus 17s is negative 1s. And then we've got the plus 8r. Okay, so when we have multivariables, we just have to be careful that we're only combining those like terms. Like number 11, we can combine 11v squared plus 2v squared. That's going to be 13v squared. And then 7v minus 32v. 7 minus 32 is negative 25v. Careful, number 12, some of them look very similar, but the only two that are 9a squared b minus 1a squared b, so that would be 8a squared b, and then plus 5ab squared. Then we've got like some little word problems. Find the sum. That just means take these two things and add them together. 14z squared plus negative 9z squared. 14 plus negative 9 is basically just going to be 5z squared. And then difference means subtract. So find the difference of 13a squared b minus negative 5a squared b. Just be careful when we subtract a negative, it really turns to addition, so this would be 18a squared b. So that is combining like terms, adding and subtracting, but we also have something new that we haven't really seen before, and it's when we are multiplying monomials. So when we multiply monomials, we use a rule called the product rule. The product rule means that we are going to be taking these exponential expressions and we are multiplying them. So we'll see like a times symbol in between two of them. But what's weird is when we actually multiply things like, for example, let's say 2 to the second power times 2 to the third power. If we were to use the product rule, we actually never do this 2 times this 2. We actually just keep it the same. What we do, though, is we take the exponents and we add them. 2 to the second power times 2 to the third power is the same thing as 2 to the fifth power. The reason why is 2 squared is really 2 times 2. 2 to the third power is 2 times 2 times 2. And altogether, we have 1, 2, 3, 4, 5. We've got 2 to the fifth power. That's where that comes from. So the formal definition is that x to the a power times x to the b power is x to the power of a plus b. It starts out simple. X to the fourth times x to the second. Keep the base the same and add the exponents, which we don't have to necessarily show this work every time, but this would be x to the sixth power. A to the fourth times a to the first. There is an invisible one there. This would become a to the fifth power. W to the fifth times w to the ninth. We add 5 plus 9, that's 14. So it would be w to the 14th power. Only thing about this is that it is going to get more difficult. Sometimes we're going to be, or lots of times, we're going to have examples with coefficients. So what we have to do is multiply the coefficients normally. For example, number 20 says 3x to the third times 7x squared. I know they're in like separate sets of parentheses, but we don't really have to worry about that. We can think of this as one long multiplication problem. And what we would do is pull out the regular numbers and multiply them normally first. 3 times 7 is 21. You do not use the product rule for regular numbers. We use the product rule just for the variables. The product rule says that when you're simplifying the variables, if the bases are the same, x to the third times x to the second, you keep the base the same and you add the exponents. This would be x to the fifth power. So altogether, 21x to the fifth power would be the answer to number 20. Number 21, we would multiply negative 8 times 2, that's negative 16. And then for the product rule, because this is not the product rule, this is just multiplication. The product rule really occurs right here with the m to the 7th times m to the 3rd. We take the m, keep it an m, and add 7 plus 3, and that would be m to the 10th power. Number 22, 9 times 3 is 27. X to the 1st times x to the 7th would be x to the 8th. Number 23, we're getting more variables now, and that's okay. Start with the regular numbers. Negative 6 times 4, normally we just multiply that, negative 24. Then we use the product rule for the a's. A to the 1st times a to the 3rd, that's a to the 4th. B to the 2nd times b to the 6th, add them up, that's b to the 8th. The order of your variables doesn't matter, but I usually keep them in alphabetical order if possible. Number 24, look for the regular numbers. Negative 2 times negative 9, that's positive 18. P to the 7th times p to the 4th. 7 plus 4 is 11, so p to the 11th. Q to the 5th times q to the 2nd. 5 plus 2 is 7, so q to the 7th. And r to the 1st times r to the 3rd would be r to the 4th power. That would be your final answer. All right, we'll do a couple more. So 25, we've got 6 times negative 7 is negative 42. X to the 5th times x to the 2nd, that would be x to the 7th. And y to the 8th times y to the 4th would be y to the 12th. Skipping around a little bit, let's do number 27. So number 27, just be careful. This is 1mn times 8m squared n times negative 1, technically, mn to the 9th. So what we would do is multiply 8 and negative 1. That's going to be negative 8 altogether. And then let's look at all the m's. M to the 1st times m to the 2nd, m to the 1st. 1 plus 2 is 3. 3 plus 1 is 4. So it's going to be m to the 4th power. This is n to the 1st, n to the 1st, n to the 9th. 1 plus 1 is 2. 2 plus 9 is 11. So n to the 11th power. Sometimes we might have some fractions added into the mix, and that's okay. You would just do negative 24th times 1/3 in your calculator. That works out to be negative 8. And then x squared times x to the 1st power would be x to the 3rd. And y times y is y squared. Okay, and then we have the mixed practice. So the mixed practice, we are going to be using both of the things that we learned so far, adding and subtracting and the product rule. Now the order of operations, like the regular old order of operations, PEMDAS, still applies in this situation, meaning that in order for us to simplify an exponential expression, we would have to first use parentheses and simplify that. But when I'm looking at number 35, inside of these parentheses, there's nothing I can do to simplify that. Inside these, nothing I can do. Inside these, nothing I can do. Inside these, nothing I can do. So these parentheses are really not needing to be simplified. They're just showing multiplication. So moving on to the next is exponents. I need to simplify my exponents. And to simplify my exponents, I then need to follow the order of operations within that. So within the order of operations of the exponents level, I have to still follow the correct order, which is always multiply or divide first before you ever add or subtract. So I know I see a plus sign here, but I'm not going to be adding anything until the very, very end. So what I would do in these types of mixed practice problems is first use the product rule to multiply, and then I would combine like terms to add or subtract, depending on what the problem is. So on the left-hand side of number 35, I would do 3x to the 5th times y times 2x to the 4th y to the 3rd. 3 times 2 is 6. X to the 5th times x to the 4th, add them up, x to the 9th. Y to the 1st times y to the 3rd, add them up, y to the 4th, plus. The next one, 5 times, technically 1, there's nothing to multiply with, so it's just going to be 5. X to the 7th times x to the 2nd is x to the 9th. Y to the 2nd times y to the 2nd is y to the 4th. Then I look to see, well, can I do more? I simplified the left, I simplified the right, and look at the variables and their exponents. If they have the same exact variables, x and y, and those variables have the same exact exponents, 9 with the x, 4 with the y, they're considered like terms. So what we do is we add 6 plus 5, that's 11, but we do not touch the exponents. It would be 11 x to the 9th, y to the 4th. So that's how the mixed practice questions work. So number 36, we would do -3 times 4 first, that's -12. A to the 4th times A to the 1st, that's A to the 5th. B to the 1st times B to the 6th is B to the 7th. And then plus, this is technically like 1 times -7, which is just going to be -7. A to the 5th, B to the 7th. Now, I'm not going to lie, a lot of these mixed practice questions are specifically designed so that when you do simplify them, you do get like terms. And in this case, we do. We would add -12 plus -7, that's -19. And we keep the variables and their exponents exactly the same. So that is the lesson for the first section of our new packet. And what I think would be helpful and what the students all did in class was homework 1. So what I would like you to do is go ahead and try homework 1 and then send me your answers, and that will count for today. And then anything that you're struggling with, it's okay if you can't figure it out or if it's wrong, we can go over the answer on Thursday and continue moving on.